Okay. Now, it shouldn't be necessary for me to review polar coordinates. In the first place, your prerequisite courses were supposed to cover this, okay? And fairly thoroughly. So, not real happy that that didn't happen, but, you know, with COVID last year, I understand how it could. And it's going to cause you to not understand what I'm going to say, what I'm going to tell you today as well, okay? You know, you got a big jump to understand spherical and cylindrical coordinates, which is what we're talking about. Not that you can't do it, it's not that hard, but you're going to have to do more digging, okay? And also remember that I did assign the chapter on parametric curves and polar coordinates, okay? And I've delayed that a couple of times to give you time to do it. So if you haven't been looking at that, I understand you got plenty of pressures from all your courses, especially from mine probably, okay? You're in a couple of tough courses with me, and I know you've got other tough courses. So I understand that, but you just got to get this. We can't go back and do the stuff that you're supposed to do in prerequisite courses and get all the way to the integral theorems at the end of this course, okay? It's a stretch regardless. Okay, well, having said that, it's not all that hard. You just got to get into it. And we're going to be using some of it today, which would maybe help you get an introduction to that, and then you can look at that chapter with fresh eyes and, you know, see it there, okay? One more another. I mean, y'all are working hard. Y'all are doing well. But we got to get this, okay? So, here are the polar coordinates. R equals 4, theta equals pi over 6. Actually more like .40 degrees, which is 2 pi over 9, okay? And if you don't know how to convert between radians and degrees, 360 degrees is 2 pi radians, okay? From that, you can do any conversion. I'll note that. Three 60 degrees is 2 pi radians, 1 degree is pi over 180 radians. And 1 radians, 180 over pi degrees, which is approximately 57.1 or 57.3 degrees. I'm just going to say 57 degrees. Something else that's supposed to be covered in second semester pre-calculus. Okay? Covered in such a way that you understand it when you get here. Now, I'm not trashing your pre-calculus course. Again, there are factors there. But more telling you that you need to master stuff as you go through it, so that when you have to use it again, all you need is a quick reminder, okay? Okay, well, there it is. But when you transfer to university, you're going to be there with people who have that all the way up to their junior level courses, okay? And you got to compete against those people. Now, people who make the grade in my courses uniformly do well when they get to Virginia Tech. Okay? So, yeah, if you're doing well here and continue to do well here, you're going to be okay. But you want to be as competitive as possible. Of course, hiring depends a lot on grade point average and stuff. can. You want to have a life when you get up there, okay? So, learn as much as you can. Okay, well, and when somebody says you need to review something, or go back and learn something, you really need to do it, okay? In a timely fashion. Okay. As I say, you're doing great. You know, so I'm not concerned. I know you're going to do what's necessary. Just think about how to time it so that it's as painless as possible. Okay. So anyhow, we have this, the polar coordinate. At this point, if a vector from here to this point has a length of 4, that's your r coordinate. And if theta is pi over 6, now that's not a real good estimate for the angle. Like I said, it's more like 40 degrees. Then that tells you where the point is. Now I've got other points, and I've got vectors looking at them. Okay? And you're supposed to estimate these. Well, you go through and estimate r. If that's 4, then that's 4, so that's probably r equals 3. That's more than 4. That might be r equals 6. I'm not taking the trouble to make hugely accurate estimates here, just giving you an indication. Maybe r equals 2 here. Basic idea, this one's shorter than this one's shorter than this one. This one's longer than this one. So r is greater or less accordingly. Angles, now I'm not going to bother with radians because you're used to degrees, and it's hard to estimate angles in radians when you're used to degrees, okay? There are certain angles that are important, and we'll talk about those. But so, you know, right now degrees is fine. So from here to here, I mean, this is 180 degrees. Looks like you're back about 30, maybe 150 degrees. Okay, and you know this angle is about 1/3 of your right angle here. That would be 30 degrees. R equals 6 here, and theta maybe 160 degrees. It looks like a little less angle than this is. If this is 30, that's maybe 20 degrees. Okay? And if the angle here is 20 degrees, and I don't know, I've got 160, 250. Okay? Because from here around to here, you were looking at it funny, so I knew I did something stupid. Okay, so from here around to here is 270, come back 20, right? And from here to here, it's not exactly 45 degrees. I'm going to say 310 degrees. This might also be a 40-degree angle. This looks almost like a right angle here, so that would be consistent. If this is 40, that would be 310. Okay? So nothing hard about that. Now in radians, you could convert these to radians. Not hard. You just, you know, you multiply the degrees by the radians per degree. Okay? Because that's what this is. And 150 over 180 is 5/6, right? So that would be 5/6, wait a minute. It's, yeah, 5/6 of 180, sorry. It's right. I don't know. Okay. Down here, 250 over 180 is 25/18, which doesn't reduce. So that's 25 pi over 18. And 310. 3 pi over 2 plus 2 pi. I don't want to do that in my head. Probably do it wrong. You can figure it out. Spread it out. You have 310 over 180, which is 31/18. Something wrong with the way I'm looking at that. think that should reduce, but it doesn't. Okay, so be, you know, that's 31 pi over 18. Looks like it's gonna be a good day. Okay, got it? So we have to have that feeling, we have to have that intuition, okay? Now graph the points where r is less than 3. Well, what are the points where r equals 3? Can you draw me some vectors where r equals 3? Okay, here. Say this vector is r equals 3. Okay? Draw that vector, and then draw several others, you know, around the plane where r equals 3. Well, they've all got to have the same length as the one you started with, right? Do they all have the same length as this one? The way you're drawing them? I mean, plausibly. You know, if you draw a vector like this, that was not a good attempt. Okay? If you draw a vector out here, it's not exactly the same. It's a little short. Yeah, probably ought to be just a little longer. But make that a little longer. What kind of a shape are we getting here? What kind of a shape? Of course, you know, we're talking about the points, not the vectors. Does it look like a square? Does it look like a bunny rabbit? Well, that's what I was thinking. I'm glad you agree. Okay? What is it? It's a circle. Because r is 3, the distance of all these points from the origin has to be 3. Now, actually, I said r less than 3, right? So it's not going to include the circle, so I better kind of get sloppy here, but make a dotted line out of this. It's going to kind of smudge, but okay, now this is a dotted line, if you believe that. Okay? What are the points where r is less than 3 then? Well, to draw a point, you draw an arrow where r is less than 3, an arrow shorter than one of these, that would put you inside the circle, right? So it's pretty obvious that the set of points where r is less than 3 would be the interior of the circle. Okay? So we could shade that. Okay, but also theta has to be less than 3 pi over 2. And actually, I should say greater than 0. Usually we say r is greater than 0. We'll do greater than or equal to 0, so we don't have to. If it was just r greater than 0, we wouldn't be able to include the origin, would we? So it'd be the interior of the circle, but not including the origin. Okay. So that part is fairly straightforward. Now, what about okay? That's 3 pi over 2, not 3 pi over 4. Where's 3 pi over 2? So you really ought to be very familiar with radians. But this is 2 pi here. Yeah, you got a fourth of that. A fourth of 2 is a half, so that'd be 1/2 pi or pi over 2, right? So, you know, go ahead and label that. This is pi. And here's 3 pi over 2 right here. And here's 2 pi. This is 0 or 2 pi. So 3 pi over 2 is right here. M theta equals 0 is right here. I draw that as a solid line. But I'm going to put an open dot here because theta has to be less than, R has to be less than 3, right? So we have an open dot here. And here we have a dotted line because theta is not going to be equal to 3 pi over 2. I'm not going to write all that out. Okay? Now, the region where theta is between 2 pi and 3 pi over 2, I could shade. Let's just shade it diagonally. And be really careful we don't. Okay, it's this region, right? Now, actually, the region where theta is less than 3 pi over 2 extends all the way out here. Okay? But the part that satisfies both of these equations is the part where we intersect the interior of the circle. Okay? So our region, I might be using too many colors here, but our region is like this. Bounded by the dotted line outline of the circle and ending at the dotted line where pi theta equals pi over 3 pi over 2, and that's our region. Slip outside the region here. Okay? So we could actually color it in. Just smear it in here, and there's our region. Come on. Okay? Get the idea? Well, how about this? All points where R equals theta. Can you give me an arrow indicating a point where R equals theta? You draw any arrow and say R equals theta. Okay? So draw any arrow. They put it in the second quadrant, just to get attached too closely to the first quadrant, okay? Okay. That's the first quadrant. We'll live with it. Okay. Don't worry about it. Don't worry about it. Okay. Now, if you drew the arrow in the second quadrant, I know you were concentrating on what you were doing, didn't you? Okay, it doesn't matter. Okay, if you drew it in the second quadrant, draw me a vector. Draw me the vector that satisfies R equals theta, but where theta is half as great. there's r theta, right? Now where is it that theta's half as great?
It'd be half the angle.
Yeah, so
And half
sketch,
the
just, okay, don't worry about r, just sketch a ray, starting at the origin, a half ray, okay? Is that a ray? Starting at the origin and going out a ways at half that angle. Well, let's see, half that angle, maybe about here. So this is, okay, I'm going to call this R naught, theta naught. And that's not like an R at t equals 0 and a theta at t equals 0, although it could be, because that's kind of the way we use the notation in physics. But here your angle would be theta naught over 2, all the way along this ray. So what would where would your point be? What would your vector look like?
R naught over 2.
Could be, theta's half as great if r equals theta. That's got to be half as long as this, right? So this is half as long. Okay, maybe I've got it half as long and maybe it's a little too long, but you get the idea. Okay? So here is the point r naught over 2, theta naught over 2. Okay? What do you get if you go twice as close as this? I mean, if you cut theta in half again?
R naught over 4, theta naught over 4.
Okay, try not to talk while I've got I know it's tempting, but officially I'm not able to use these videos if we talk. And if I could get Zoom working, I could pause Zoom and we could talk, okay? So I intend to get that done, but my camera disappeared. I don't know how long it's going to take to get a replacement. Guess if I pay out of pocket, I get one tomorrow, but I don't really want to do that. First place, I'm not sure it's really gone, but there's no place. That's 2 cameras that have disappeared out of this lab. Before it disappeared from, there's a much more expensive video camera, like that one, sitting right next to it. So I don't think somebody came in and picked it up. I think I did something stupid, leaving it laying someplace, and somebody just took it off. That's mine. So, anyhow, so it's kind of on me, so maybe I just better bite the bullet and buy one. Okay, anyhow, we got R naught over 2, theta naught over 2 here. And now we've cut theta in half. So we're going to have an R that's half as great, right? And then we could start drawing other angles. We draw an angle halfway between this one and this one, which would be maybe about here. And now R would be 3/4 as long, so maybe your point's going to be out here, right where I labeled this thing. Okay? What's going to happen if theta is 0? What's R going to be? Well, it's going to be 0, right? If R is 0, where are you? You're at the origin, right? So here we are at the origin. Now we come out here like this. We come up here. I'm going to try not to. And we come out here. What kind of a shape does it look like I'm starting to form here? It's a, don't say it. But what's it start with? Can you trace out the letter? Yeah. And limited shoulder motion, so I can't go beyond that. But Okay, it's gonna be a spiral. Okay? And as opposed to a logarithmic spiral, it's gonna be an Archimedean spiral. We don't need to know that. We could double this angle, just to see where it's gonna be by the time we get way down. Let's see where we're gonna be. We're gonna be twice this far behind the x-axis. If we double the angle, okay, this is two theta naught, and the vector's gonna have to be twice as long. We're going to be down about here, so this is just going to come around like this, and it's going to keep going around. And of course, theta doesn't stop at 2 pi, does it? So this thing just keeps on spiraling. Okay? Challenging my locked-in shoulder. Okay? That's its whole purpose, just to make it inconvenient for me. Okay, you get the idea, right? Okay. Now, there's another way that we often graph equations like this. And of course, we've got to know basic angles. You're going to need this for physics, too. Can't do simple harmonic motion without the picture. So, and sometime fairly soon, I'll tell you how that works out in physics, but here we go. Okay, so here's pi over 4, pi over 2, 3 pi over 2, 2 pi, or 0, depending which one you want to use, okay? This is 2 pi half, and that is pi over 2, right? Okay, hang on. We got a disagreement, and it's about time to pause this anyway.